Okay, dots and ties. In this lesson, we will explore two ways to extend note values, dots and ties. A tie is a curved line that connects two or more notes of the same pitch, combining their durations into one longer sound. A dot, or augmentation dot, is placed to the right of a note or rest and increases its duration by half of its original value. So the total becomes 1.5 times as long. Let's start with the tie, because it's simpler. A tie is a curved line connecting two notes of the same pitch to create one longer sound. So we can see it here. I'll add it. Notice that both of those notes are F on the top line. We can only tie two notes of the same pitch. When the notes are tied, their note values are added together. So in this case, a quarter note F, 1 beat long, tied to another quarter note F that's 1 beat long, becomes a single F that lasts for 2 beats. We can listen with and without the tie. So with the tie, I'll play it. Hopefully you heard that the F on the fourth beat of the first measure continued through the first beat of the second measure, 2 full beats of the same sound. Without the tie, you hear the 2 distinct F notes separately. So without the tie, and then with the tie again. Okay, let's move on to dots. The augmentation dot adds half of the note or rest's original duration, so the total becomes 1.5 times the original value. The easiest way to see this is to compare a dotted value to its next smaller division. So, as we can see in the graphic here, a half note, the next smaller division is quarter note. So a half note normally equals 2 quarter notes. If you have a dot, it equals 3. Another example, for quarter notes, the next smaller division is eighth. So a quarter normally equals 2 eighths. We add a dot, it equals 3. Same goes for eighth notes. The next smaller division is 16th. So an eighth normally equals 2 16ths. We add the dot, and it ends up equaling 3. The pattern is that the values will normally divide into 2 and will divide into 3 when dotted. Okay, looking at a rhythmic grid. Just like the duration grids we saw earlier, we can click notes to compare values. You'll notice the notes relate to each other exactly the same way as they did in the regular note duration grid. This is because dotting preserves the same ratios. If a whole is equal to 2 halves, then a dotted whole is equal to 2 dotted halves. A half equals 2 quarters normally, so a dotted half equals 2 dotted quarters, and so on. Let's get some practice. How many dotted half notes will equal a dotted whole note? So I'm going to click the dotted whole, and I'm looking at dotted halves. There are 2 dotted halves in a dotted whole. How many dotted 16th notes equal a dotted half note? So I'll click one of the dotted half notes, and then we'll see that there are 8 dotted 16th notes in a dotted half. A few more. How many dotted eighth notes to equal a dotted quarter? I'm going to click one of the dotted quarter notes. There are 2 dotted eighth notes there, so 2 dotted eighths to equal 1 dotted quarter. How many 16th notes to equal that same dotted quarter note? Well, I see 4 16ths, so 4 dotted 16ths equal a dotted quarter. Finally, how many dotted eighth notes equal a dotted whole note? So I'm going to go back to the dotted whole note, and there are 8 eighth notes in that dotted whole. Things can get a little bit tricky when comparing dotted notes to regular notes. We need to subdivide the dotted value. Again, subdivision means splitting a note's duration into equal, smaller parts. It's especially useful when comparing dotted notes with standard durations. The rule of thumb, first convert any dotted note into 3 of the next smaller value. For example, a dotted half becomes 3 quarters. A dotted quarter becomes 3 eighths. A dotted eighth becomes 3 16ths. After that first step, compare using the usual relationships. Each quarter is 2 eighths, each eighth is 2 16ths, and so on. Let's look at the examples. Example 1 starts with a sample exercise prompt. How many 16th notes to equal a dotted half note? The chart on the right shows the solution. First, we subdivide the dotted half into 3 quarters. And then we split normally. We split each quarter into 2/8, that gives us 6. Finally, splitting each eighth into 2/16, giving us 12 total. So the answer is, there are 12 sixteenths in a dotted half. Here's our second example. How many eighth notes equal a dotted whole note? So first, we divide the dotted whole note into 3 halves. Then we divide normally by 2s. Each half becomes 2 quarters, so that gives us 6. And each quarter divides into 2 again, that gives us 12 eighths. So there are 12 eighth notes in a dotted whole. Third example, this is a simpler one. How many 16th notes to equal a dotted quarter? Well, a dotted quarter will divide into 3 eighths, and then those eighths each divide by 2 into 2 sixteenths, and we have our answer, 6 sixteenths in a dotted quarter. Example 4, how many 16th notes to equal a dotted eighth? Well, a dotted eighth immediately divides into 3 sixteenths, so we're done. There are 3 sixteenths in a dotted eighth.